Okay, so we're going to start on section 7.8 here. There's a couple equations that we're looking at from this section. We're going to start out with the one called the trapezoidal rule. And this will let you approximate. Basically, the idea is if we have a curve, so say we have some sort of curve, and we split it up into even chunks, we can take the starting value here and form a trapezoid from here over to here and use trapezoids from the starting point to the stopping point on each of these. We can use trapezoids to approximate the area under the curve. So you have basically these trapezoids, and we'll use them to approximate the area under the curve. So for the trapezoidal rule, we say the nth trapezoidal approximation to the expression integral a up to b of f of x dx is, so we get Tn to represent trapezoidal approximation, and the n tells you how many bars you're going to break it into. It's 1/2 times delta x, and then we have y0, the starting point, plus 2y1 plus 2y2 plus so forth and so on. They each have these 2's till you get to the 2yn minus 1. When you get to the very, very last one, you don't have a 2 in front of it anymore. So the first term and the final term don't have 2's in front of it. All the in-between stuff does. And then in this approximation, we get a couple other things that we want to note. We get in this situation delta x. It's the interval length b minus a, and you divide it by the number of chunks that you want to break it up into. So it's interval length divided by how many pieces we break it up into. And in this expression, the y sub j's are equal to the function f evaluated at a plus j delta x. So if you're trying to use the trapezoidal rule, since there is a delta x, you need to apply this rule here to equal spaced items. So if you have anything where like the x values, the length of each bar is not uniform, you can't apply this rule there. Furthermore, we should also note that the nth trapezoidal rule is also 1/2 of the right endpoint approximation plus the left endpoint approximation. So this is a nice rule that we can use. And we especially use this if there's not a uniform bars, if the bars are different lengths. So I guess what I'm saying is if the length from here to here is uniform, so if that distance is the same as this distance, is the same as the length of the width of the next bar. If those are uniform, then you can use this equation. But if those aren't uniform, then most of the time you want to use this secondary representation to find the right endpoint approximation, the left endpoint approximation, and you add them together and divide them by 2, which kind of takes their average. And why this works is if you kind of look at, let's say we have a thing and we have a single bar. The left endpoint approximation in this case would create a rectangle like that. The right endpoint approximation would use this. And if you think about it, this takes the average, which the average should be the halfway between the distance between the right and left endpoint approximation. If we look at this little box here, say, this box, if we were to draw a diagonal line straight through that box, that would cut the difference. So we draw a diagonal line like that. That would be the average between the right and left endpoint approximation, which we could see that will form that'll form one of the trapezoids from the trapezoidal approximation. So that's kind of why this works. It's basically the left endpoint approximation is the taller one in this situation. The right endpoint one is the shorter one. So their average would be what happens if you cut that distance in half. So we diagonally cut the difference between those two bars in half, and that gives you the trapezoidal approximation. So we're going to do an example real quick here. So they give us a table with x and f of x. So this is a table of values. And we'll note that the table, the numbers are not spaced evenly. So since they're not spaced evenly, we can't use that first equation, like here's a jump of 3, here's a jump of 2, jump of 3 again, a jump of 1. So we can't use this one because there is no delta x. There is no common uniform spacing of the x's. So they're going to have us with these values, they're going to have us find the trapezoidal approximation. And we're going to have to do it by finding the right endpoint and the left endpoint approximations, and then take their average by this. So they want us to use the trapezoidal sum to approximate the integral from 1 up to 10 f of x dx using the table above. Okay. So we will find the right, we're going to use the right endpoint and the left endpoint approximation, and then we'll go through and we'll figure out the trapezoidal approximation based off of that. So the right endpoint approximation, the first interval is length 3, and the height I use is the, so 7 is the left value, 2 is the right value, so I use 2. Plus, the second bar will be length, it'll be width 2, 4 up to 6 is 2. And I have 2 as the left value, negative 1 is the right value. I'm doing a right endpoint approximation, so I use the negative 1. The next 6 up to 9 is 3. I have negative 1 and 3. 3 is the right number, so I use 3. The final one, 9 up to 10, is 1. I have 3 and 5. 5 is the right-hand number, so I use a 5. So total these up, I get 6 plus negative 2 plus 9 plus 5. So 6 plus negative 2 is 4. 4 plus 5 is 9. 9 plus 9 is 18. So my right endpoint approximation is 18. So now I need to come up with what is my left endpoint approximation. So the width here is 3. I'm going to use the left-hand number 7 for that first bar. So I get 3 times 7. The next bar, 4 up to 6 is 2. I use the left-hand number this time, so I use the 2 down here. So we get 2 times 2. Plus the next one, 6 up to 9 is 3. Negative 1 is the left number, 3 is the right number, so I use negative 1 because I'm doing a left endpoint approximation. So I have 3 times negative 1. Plus for the final bit, 9 up to 10 is 1 unit long. 3 is the left, 5 is the right. We're doing the left endpoint approximation, so we'll use the 3. So I get 21 plus 4, which is 25. Take away 3. 25 take away 3 is 22. Add 3 back. 22 plus 3 goes to 25. So I know my left endpoint approximation. I know my right endpoint approximation. So I'm going to do this equation right here and say to get my trapezoidal approximation, it's 1/2 right endpoint plus left endpoint. So we'll have trapezoidal approximation is 1/2 times 18 plus 25. Let's see here. What's 18 plus 25? 5 plus 8 is 13. So that'd be 43. 43. And if we take 43 and we cut 43 in half, let's see, 42 cut in half is 21, so this would be 21.5. And that would be our trapezoidal approximation. So that is what we do for example 1.